Thank you, Rachel. Thank you, Mike. So we are right on time to start our panel. So this panel is all about synthetic data. It's about challenges and future directions. It's moderated by Christine Tass from Nexus Research, and she's going to be joined by Paul Tewald from Mostly AI, Ryan McKenna from Google, and Shlomi with the famous paper HOD from German Federal Institute for Employment Research. Please welcome them up to the front.
Let's go here, yep. And I think the next thing we're going to find out is if we sit down, how many people can actually see us? Okay. All right, so we're good. That's good for you guys. This may be an unsolvable problem. Enjoy us for the radio play that we're about to present on synthetic data. All right. And I will say links to awesome papers and resources will be placed in the Slack after this conversation. All right. Okay, so I think first we're going to do just brief introductions, and then after that we'll do longer introductions. So introduce by sort of name and workplace and affiliation sort of thing, and then next by your use case. We'll have each of you sort of discuss a synthetic data deployment use case that you've been working on. So Ryan, do you want to start?
Yeah, I can start. So my name's Ryan McKenna. I am now a research scientist at Google. I previously was a grad student at UMass Amherst and actually got into synthetic data thanks to the competition that was organized by Christine and Gary. And I had previously been working on a tool that I thought was, originally synthetic data was not the main intention of that tool, but it turned out to be a pretty good application of it. And then for a few years, I stopped working on synthetic data. Now at Google, we're very interested in synthetic text, and we're dealing with a lot of problems related to scale. So scale is both very good and bad. With more data, you can get better utility, but it's obviously harder to work with. So now I'm getting very excited to be here.
Cool. Thank you. Shlomi?
Hi everyone, I'm Shlomi. I'm mostly working on deployable responsible AI. What tools, practices, theory we need to deploy responsible AI in practice. I do have one focus about differential privacy, about the deployability of differential privacy. And I think today I will talk about one of my PhD projects about releasing Israel National Live Birth Registry with differential privacy.
All right, yeah. My name is Paul Tewald. I'm working at Mostly AI. I think I'm a principal AI researcher. That's my job title. What is Mostly AI doing? It's a startup, 8 years old, based in Austria, and we provide the tools for creating tabular synthetic data. So by beginning of this year, we went open source, and companies can use our tool or our frameworks to train models on their data and make synthetic data out of that. In general, we try to foster data democratization. So I mentioned briefly in my talk yesterday, we have the synthetic data part, but we also strongly support easing the interaction with data in general for people that might not have a degree in computer science, but can leverage LLMs and the likes of that.
Thank you. I think we'll do reverse order coming here. I'm going to ask everybody to explain a use case for synthetic data, and that includes what's the algorithm that you're using, and what was the input data like for that algorithm, which may have one input data or many different types of input data, but sort of the assumptions about the input data, and what was the value that users were trying to get out of that data. If there's a specific one or more general. I know everybody here has worked on multiple things, so just pick a good one to talk about.
Yeah, maybe I'll share two. So one is actually pretty similar to the refugee data that we heard before. And to be honest, those are the dearest to my heart, coming from a public entity. So I also mentioned that yesterday in the talk. It's a research consortium, and they were in a completely different domain that I wouldn't have thought about, to be honest. It's the energy sector, right? And they were, they have the issue that energy performance certificates, like every building has an energy performance certificate, and those, apparently that's done in Piedmont, in Italy, and those certificates belong to the authorities, apparently, in Italy, so it's difficult to share, right? It's private data, you know. So what they did, they created a synthetic version out of that and made the data available in a dashboard. So kind of every line is a synthetic building with all the parameters, and you can click and drag and drop and do some things. One thing I have to say about the open source part, that makes it kind of difficult to to interact with people who we are super happy about every user, but in a way there's also now a larger distance. So they reached out to us when they were already done, and we had some conversations and said, oh, maybe you could change this and that, and because I'm sure we can improve utility when helping them. But yeah, so that's a bit distant. So that's one, and the other use cases are more in the bigger corporates. So we were working with a large healthcare insurer in the US, and they had exactly the problem of taking an awful long time until they could provide data to third parties, right, partners. So they were creating a synthetic database. I don't remember the name exactly about that. Again, similar, a couple of tables, a handful of tables, created a synthetic version of that, and then we're able to reduce the time for partners to start developing before then integrating that into their production system on the real data. Yeah.
You'd say just a bit about the algorithm that you use?
So that's the algorithm that we published beginning of this year. I think I went a bit in detail in that yesterday. So we tried to really do a kind of an autoregressive approach on several levels. So you have autoregressiveness along the column domain, kind of you predict one distribution, and then the next column conditioned on the first column. Then you kind of go a step up and do the same along the time axis, which allows you to synthesize time series data. And then you can even go a level higher and say, okay, wait, when you have a database and the schema, you can put like a conditional chain or autoregressive chain along this tree, and then generate tables in an autoregressive way. Yeah.
The unit of privacy there is one building or one patient?
Say it again, the privacy
The unit of privacy is
so
one
exactly,
building,
good point. So by default, it's like you start out, I mean, that limits obviously the approach a bit, but you start out with the main table, the subject table, and that's the unit of privacy. Yeah.
Nice. Thank you very much. All right. I'll pause for just a second. Does anybody in the audience have questions about Paul's use case at this moment? Maybe you all saw the talk yesterday. Okay. Shlomi, let's hear the next one.
Yeah, so the registry we're talking about is basically a registry of all the birth in Israel. Everything is documented there. The Israeli health system is rather centralized. It's something like the UK system, the German system. So it's happened to be that the Ministry of Health is they have a lot of data about the first years of life of people. And they wanted to release this data. So in that point of time, before the project, only if someone was a medical researcher and we need to go via a vetting process, you could get access to this data in kind of enclave environment. But they wanted to open that for example, if you're economic researcher, you have no chance to get access to this data. If you are civil society, journalist, etc., you cannot get access to this data. Another funny thing, I hope we are not being recorded, but they also told me that, for example, if someone from the finance ministry want to have access, they cannot give them access. And part of the reason, because if they would say, oh, we need more budget and stuff like that. So there was a really kind of very funny situation that one specific audience or a group of people can get access to this data. So their idea was to release this data, and that's hopefully increase, maybe having more access. And regarding the algorithm, I think in this specific case, the specific synthesizer is actually not the interesting question. So going back to what Rachel said about their dream to have, you just click play and re-release. So I will want to put a vision for how I want to see the world do DP releases or synthetic data releases. I don't think data curators need to think at all about the algorithm that need to be used or whatever. I want to have a language to describe different requirements, being able to say, look, this is our privacy requirements, and we have a language to describe it. This is the utility requirements we want to have, and we want to describe it. Being able to describe trustworthy requirements, maybe later I will say more about that, which kind of the space of algorithms, and not only that, the space of data representation. Many times when we release data, there is more than one way to do binning for the data, and that might be acceptable by the data curator and data user. So there is no reason to commit for one. And kind of part of doing this release, kind of what we have seen, that the combination of data binning and hyperparameters and algorithms, it's kind of, some combination works really well in terms of utility and privacy, and it's really hard ahead of time to anticipate what is going to work. Like it's like kind of one of the basic lesson we have from machine learning. So my hope is like we'll be able to specify that and then output the release data set. And actually this is something we did in the work. Like we work with the stakeholder, and maybe later I'll talk about this more, doing this kind of specify utility requirements and all of these aspects. And just, there was kind of algorithm running and choosing the best synthesizer to use and so forth, and just outputting a release that we actually released at the end.
So if I would ask, if I would ask Shlomi about which algorithm he used, I gather it's all of them. Is that, or not all of them, but like a
Yeah,
selection?
so we have, back then, we kind of really took only algorithms that they were a trustworthy implementation, that they really trusted them, because as we know, there is tons of bug in them. We didn't have AIM back there, but for sure, probably that will be the one that won at the end is PriveBase. I'm willing to bet, yes, PriveBase working really well if you tune it well, yes.
Oh, fascinating.
AIM now going to be work the best for sure. But we use kind of a technique called private selection. It's actually a small line of work, but I think it's really neat trick.
This is the magic part. Everybody pay attention.
Yeah. So basically, if you have an epsilon DP algorithm that output the result you're interested about, for example, the synthetic data itself, and some quality score, okay? Number between 0 and 1, for example. Now, if also both the synthetic data and the quality score are all DP, this whole thing is epsilon DP. So now I'm going to give the simplest version of that. There is like very many variants. Run this mechanism over and over again until your score is higher than a predefined threshold. You're just going to pay 2 epsilon.
So to recap, and this is the magic part, and Shlomi's going to put the paper in the thing and you can all read it, but we're adding noise to the quality metrics that we decide when a release is good enough. And you can make as many releases as you want, and as many configurations as you want, and a giant pile of all of these things. You can't tell anybody how long you ran it, and you pick the one that pops up high enough.
Yeah.
And you're good for a relatively low epsilon, and that is magic.
Yeah.
And I want to say, so going from the two of you and to foreshadow for Ryan a little bit. So when we've been thinking about synthetic data, everybody loves synthetic data because data is a nice interface. It's the way we say it, right? So if you're talking to folks that were used to doing analysis directly on the data, if you can give them synthetic data, they can do analysis on that, is the theory. You need to be cautious about it because, of course, when you're doing things differentially private, things aren't going to be accurate all the way down to the individual level. You like to hope that whatever analysis they were doing on the data before, it was also not tracking down individuals. But if you can get synthetic data working, it's great. And we look at, so energy efficiency, healthcare, economic analysis, all these good use cases. But it's been a difficulty of, so when the software is user-friendly and open source, folks go and use it and still need like helping hand to get the utility right. And you're picking these use cases sort of one at a time and getting them kind of bespoke. And that's unfortunate for the thing that once you've got it working is the easiest thing for people to work with. So I think what you've got described there, if we can get that going at scale, that solves a lot of those problems. Utility metrics become super important then, because that's how you're deciding who wins. And communicating about them becomes very important. But I want to say, so Ryan, whose name, as has been mentioned before, has been mentioned a lot over the past few days and did foundational work in synthetic data here. And now at Google, I know one of the things you're looking at is how you get a big tech company to find, these use cases and to get adoption internally, right? Because here we have sort of these one-at-a-time adoptions, but something that Google starts providing things for everybody,
Right.
there may be a lot of adoption. So how are things going at Google? Tell me about your use case.
Yeah, so I guess at Google we have like sort of two different work streams, one centered around tabular synthetic data and one centered around text synthetic data. And we're figuring out ways to unify them, as I talked a little bit about yesterday. But yeah, I think what we're trying to do is design sort of the right, APIs so that it is easy for these things to be self-serve rather than one at a time, and making them sort of work well out of the box so you don't need to do that hyperparameter tuning in the first place. But the use case I wanted to talk about was something that my team has been involved in since before I even joined Google, and that is Gboard next word prediction. So if you have an Android device and you're text messaging people, your phone will predict what the next word is that you're going to type. And the way that model is trained, and now we're looking at the way that model is trained is with like a federated learning and differentially private solution. So it brings in a lot of different privacy-preserving technologies, and that makes a very compelling story for the privacy of the user's data, which never leaves your device. Your text messages will stay on your device fully, but then through some aggregation process and careful clipping and cross-user aggregation in a secure manner using gosh, I can't remember the name of the secure aggregation, I think is the name of it. You can aggregate across many clients, compute a gradient, clip it, add noise, and there's a whole body of interesting mechanisms for actually privatizing this whole process. And we are looking into like, okay, can we use these models to generate synthetic text messages or things of that nature? So I think there's definitely a lot of challenges when you don't have access to, not only you can't just read the access like, when I was doing research, I can load in a pandas data frame into a Collab notebook and I can run my mechanism, it's all easy. Now, data is distributed across client devices, you can never inspect it directly. There's all kinds of, processes and approvals and technologies you need to learn in order to even do anything here, which can make things very challenging in addition to the scale.
That makes sense. So as soon as we get one thing working a little bit easier, the next thing will be harder.
Yeah.
All right. So I do want to say, so coming back to Shlomi's magic paper and the dependence on the utility metrics, and I know you put a lot of, we're just going to read this paper when we're done. There's a lot of emphasis then on getting those utility metrics right, really understanding what we need to maintain about the data. Not only that, I imagine that's from work I have done with data users and data stakeholders, helping them understand what they need from their data. And I don't mean talking them out of what they want from their data. I mean, a lot of times if they've had direct access to data before, they may not be thinking about which queries are the more stable, unlikely to be sensitive to specific individuals and so on, or how to explore data efficiently. So there's sort of like, what are the quality metrics? Probably something we still need to help them understand and still need to make sure that the synthetic data is matching those with any technique. So can you tell me a little bit about when you've been working with stakeholders, how do you find what it is that they need? What are things that they need? Whoever wants to talk first. Oh, cool, I've got to pick one. Shlomi, do you want to start?
Yeah. So one important aspect of this release, we really took a participatory co-design process. meaning we had collected a group of stakeholders, and we actually did a design with them. I'm kind of was a facilitator of that and maybe providing some expertise on differential privacy. But it was kind of literally, not literally, in a Zoom sitting in a round table together. And I think that was really important to build trust and also kind of digging in and understanding which kind of analysis they might want to run. So we did a bunch of things. First we did a literature review with them of like other analysis being done on this data set and kind of really, we created worksheets. I love worksheets. Worksheets of kind of figure out which queries are being run and so forth. We talked with them on their own research. We had a lot of conversation around that. And really, it was starting for a very long list of queries and then trying to see pattern or matching. For example, they do mention different K-way marginals. So we can collapse all of that to one aspect of K-way marginals. So one thing we actually did was not only by creating this list that was, at the end of the day, very diverse list of queries, we also kind of did, and this was actually more difficult, setting maximum error they're willing to live with, right? Like saying, for example, if you're going to give me compute averages of birth weight, the maximum error we're going to live with is 100 grams. In that context, by the way, this is literally the noise of scaling a baby and being lazy on putting the right number. So we really worked very systematically through all these kind of queries. And the approach we took specifically in this release was setting for each family of queries maximum error. So as Christine mentioned before, because we wanted to release also the queries, the error measurement with DP, taking a max error makes life much more easier. If I would done it from the beginning, for example, one thing I would like to add is bounds on the tail. For example, 95%, I think it was mentioned before, 95% of the queries have this amount of error. This is a bit more difficult to release with DP, but it's just work we need to do. So we really defined this acceptance criteria, and that was ultimately this kind of engineering approach was we're going to release this data only if we pass all the acceptance criteria. Not only that, we have very detailed README for different stakeholders. We've detailed explain each one of them. So when a user is going to get this data, it's get not just with privacy guarantees, I wanted to provide them utility guarantees they can have as well.
Thank you. And Paul, so you guys have supported a number of different customers, and what's your usual procedure at Mostly AI for both differential privacy, but also a lot of non-differential private synthetic data work?
So I envy Shlomi for, it seems that your customer, the people you were working with, had a very clear idea of where they were.
No, it was a lot of time to...
Okay, got it. Yeah, that is a good question and maybe a problem we can discuss later, but people reaching out to us often don't really know what the downstream final use case or use cases for the synthetic data might be. So we always try to aim for obviously high accuracy and try to guide them and say, okay, look, we provide tooling, also open source, which gives a basic overview of the data. By the way, that is also super helpful for them because that's one of the few times they actually see their data, right? They see all the univariate distributions, then this correlation matrix, and sometimes they are super happy about only that, right? Just to see their data in that aggregated form. So that's what we provide and say, okay, this is the first sanity check, if everything is all right, and then we say, okay, what are potential next steps? Are you gonna maybe train a machine learning model on that? Do you want to test that? There's this train synthetic test real framework and stuff like that. So I have the feeling we are pushing, and the downstream use cases are more often than not really unclear. So that's unfortunately a bit problematic. Yeah.
But it makes sense. You find a set of metrics that most people understand, and you're dealing with customers who, like you said, may not have been looking at their own data due to sensitivity concerns. So now finally they have some access.
I wouldn't even say that it's sensitivity concerns. They
Just weren't even looking at their own
haven't
data.
looked at their own data that way, at least. Yeah.
That's great. And I do want to say, also by way of additional introduction, so as far as our relationship, NIST has been doing synthetic data benchmarking and synthetic data challenges, and I've been leading that work for NIST from Nexus since 2018. If you look at the collaborative research cycle, which I will stick up as a link on the Slack with everybody else's links that everybody else is going to stick up on Slack, that shows benchmarking results across very many different data privacy approaches, differentially private ones and also non-differentially private ones. And the non-differentially private, mostly AI solution, which is the one we have up right now, is one of the best performing for utility and privacy on the proprietary solutions. So yeah, just a plug for that. Okay. No, but this is this interesting problem of finding out what people need and then making sure you're able to provide that. Ryan, how's that going sort of inside a big organization?
Yeah, I mean, I've seen a little bit of both, where some people will come in and they know exactly what they want to do with the data, and that's phenomenal. And then I've seen a bit of like, say, hey, we want synthetic data, and I ask them, what do you want to use it for? And then radio silence for a week. They just it's tough to engage with that. And I feel like from the mechanism design perspective, this is something that I feel is very important. It's important that you can configure the utility of your synthetic data towards whatever it's going to be used for. And so that's been like a central design goal for me. But then also there should be reasonable defaults. Like if someone doesn't know what they want, you can just optimize it for general purpose utility. But yeah, at Google, we've seen a little bit of both, I think, in that regard.
All right. Can I say, so what are some, as you guys have been navigating these spaces, do you have any suggestions for like neat tricks that you found work? So neat tricks for communicating with people, for doing evaluations, for making the synthesizer perform better, general philosophy.
Actually, I will say one more thing about the last thing I forgot to mention is oftentimes some people, and I think it relates to the current question, some people who maybe are not DP experts are very concerned about the fact that like the tail of the distribution or bins with small counts are not preserved well. And that's something that's sort of like hard to communicate sometimes, like maybe it's a fundamental property of DP and a desirable thing. But there's going to be certain things where it's just not going to work, and I guess I'm open for suggestions on how to communicate things better to people who want to use this type of thing.
All right, so before we move on to the neat tricks thing, what are the types of roles that you run into when you're trying to have these conversations, or do you find there's like confusion coming from sort of certain folks or is it just sort of?
I mean, it's mainly like, I think I saw a diagram recently, like in an ideal world, maybe it was even, I can't remember which talk it was, but in an ideal world, you would have a privacy expert, you would have a domain expert, and you would have like, you'd have like a unicorn that's an expert in 3 different things, and that's sort of not the way it is. You've got your DP experts and you've got your domain experts, and oftentimes these are different people. And so, yeah, I think, I don't know if there's a good solution for that.
How do you help the domain experts communicate with the DP experts, or the DP experts have expectations that are waiting for the domain experts, so you know what questions to ask the domain expert when you meet them. Because that's true for having to configure for different data sets too. So Stu, I know Mostly AI has been configured to run on a variety of different data sets. Are there tricks that you have that help with that, or?
Well, that's a good question. I was more, by answering the question, I was more leaning it towards the communications part.
Fair
actually.
enough.
But okay, maybe to the configuration. Are there tricks? I think Ryan leaned into that a bit, having good defaults, right? I think a super important, for us, a super important aspect is make it easy, right? So that people get at least started, even if the synthetic data is shitty. I mean, in terms of utility, it doesn't matter, right? They load the Jupyter notebook, they press enter, and they get a result. I think that's super important. And then we can talk about the rest, right? And in terms of configuration, it's with our algorithm, it's really mainly the the encoding types of how you treat the different categoricals, numericals, and stuff like that. Make sure that you have the right encoding for the right column. That's, I would say, our main handle, and sometimes people get it very wrong, and sometimes our defaults get it wrong, and that's, I would say, that's the main handle. Maybe quickly for the communications part, that was a super interesting journey. So mostly I was founded, I think now 8 years ago, and I was the happy place to be the first employee. So my almost first real job in a startup, and then seeing how the thing grows was super interesting. And also back then, the synthetic data community was, well, almost non-existent. So it was super, super fresh. And there was an awful lot of groundwork we had to cover. And the best thing here was really, produce content that serves a lot. You build trust, you educate people, you get some marketing, obviously, as a startup. And yeah, and that's was and still is a super, super important aspect to.
That makes sense. Produce
get things
content.
going. Yeah.
Did you have anything you wanted to add, Shlomo?
Yeah, so I really think the most important aspect of the release I worked on, I think it's also in general, is the co-design process. Like working with the different stakeholders in an iterative way and coming with drafts and proposals and work with them together. I can give a very concrete example of a requirement, what I call trustworthy requirement that came up, that I would never imagine someone would ask for that, but it seems it was very important for the adoption. So when we said, DP and synthetic data, the first reaction actually of our stakeholder in the industry was like, no chance in the world you're going to do synthetic data. We want microdata format, but there is no chance you're going to be synthetic. And I was like, oh, there is no project, fine. But then, yeah, and they really came up with two reasons. One is apparently back then, like in the medical community, there was a bad reputation in terms of utility for synthetic data. But that's we work with acceptance criteria. This was the easy one. But then they said the following. Like, we are going to release national registry, right? From perspective of transparency, people might say you're releasing fake data. You're trying to hide something if you use synthetic data.
Okay.
And then we closed the Zoom room, spent hours, and I really wanted to understand this concern. And what it came up at the end is the following statement. They want the following statement to hold true. That there will be correspondence for every synthetic data. It's going to be correspond to a real birth in the world and vice versa, right? That sounds like, okay, we cannot do that with DP and synthetic data. How do we do that? But then the realization, this is what we call it the faithfuls requirement. And we could actually satisfy that because there was no statement on how you generate the synthetic record. There just need to be a correspondence. So I can find post ante, I generated synthetic data. I just need to argue there is a correspondence one-to-one between the group of records, right? So what we did, it was actually part of our acceptance criteria. After we generate somehow synthetic data, a release candidate data set, we could find a matching one-to-one between records. So of course, to define matching, I need to say there is some errors allowed between this matching. It did work. And I can, in the release, I think I don't remember the number, but 97% of the release record can be matched one-to-one to a real-world method, and the error between them, they're quite similar.
Yeah.
And the moment I said that for every stakeholder, oh, that's synthetic data, that's fine, we're okay with that. It's really captures something very deep from trustworthy perspective of people's synthetic data. Now, we can do the math. In terms of utility, it gives you nothing. I'll just very technical for a moment. At the end of the day, it's kind of doing Wasserstein distance. So it gives you nothing on the very granular level. It's just description of the two distributions are somehow similar.
So A, that's fascinating, and B, I think the fact that it went so nicely for you is a good indicator that your magic trick works as far as producing good quality synthetic data. Because something we have seen, so if you have poor quality synthetic data, something it will do is introduce sort of funhouse mirror bias and artifacts into the data, right? It'll take some subgroups and it'll make them really big. It'll take some subgroups and make them really small. It'll take some people and sort of lean them over here. And if you were to go grab a generic data generator and run it on default settings that may not be that great default settings, if you then went to do Shlomi's exercise and match each record from the real data to a record from the synthetic data and look at the distance, like the closest matching distance is essentially what we're getting here as an error metric, you'd find it was a big distance, right? And this is something that we find when you're talking to stakeholders, is that sometimes their intuition for like, hey, I want to do this check is born out of the fact that if you Google synthetic data, you will see synthetic data vault pop up as the first result. If you take their default algorithm, it's FastML.
Yes.
FastML is Gaussian copula. Gaussian copula turns your data into beach balls because that's what it is. And so what I mean is whatever the curlicues and interesting parts of your data distribution was, never mind your data distribution wasn't really Euclidean for most people. It shoves it into Euclidean space and it makes it into a multidimensional beach ball. And so folks have instincts for what may go wrong that at first sounds silly to you, and then if you think about it, there's actually something profound we got to go fix there. That's my rant on that. So, yeah.
Just briefly comment, that's super interesting to hear that your client actually wanted a more or less a one-to-one match, if I understood correctly, because in our case, we experienced the opposite, right? Because again, we also have to educate them a lot on privacy and information leakage. But in our case, it's different. They say, oh, wait, there is one record in the original data, and there is the same record in the synthetic data in a maybe 3-column data set with 2 million rows, right?
Yep.
And then we say, yeah. No, we cannot do that. We would publish a real record, and stop, right?
So I will say what we like to do for that one. We have a apparent match metric. So this is on the SDNIST library in the CRC thing. If you say, the idea is, okay, this person looks like my friend Bob. This person I found the synthetic data looks like my friend Bob. Are they actually Bob? So you pick some public fingerprint variables, or quasi-identifiers you expect to be able to look up Bob by, like age and sex and whatever. And if there is some people that look like they might be Bob, you look at, on average, how much do they resemble Bob for the rest of the record, right? So how different is the fake Bob from the real Bob, essentially the inverse of your thing. And you can go say, oh, here's a nice distribution of only, if an attacker believed that was Bob, they would be only like 40% correct. They'd be wrong 60% of the time when they tried to guess the other variable values. So I mean, that answers. Yeah. But I will tell you, if you do differentially private histograms with epsilon of 10, you get a nice little bump there where that is Bob. You can get some of these ones that don't actually do much to the data, and it's a click over 100%. Ryan, did you have thoughts on?
Yeah, I mean, I guess my thoughts on, the broader question is, I guess when you have data that's very, going back to the question of tricks and things and how do you get things to work in practice, if you have data that fits neatly into the assumptions made by a lot of the mechanisms for synthetic data, such that, okay, you have categorical data and the set of possible values is not that large, maybe 10, maybe 100, then the mechanisms might work well for you out of the box. But then when a real world customer comes in, they don't often neatly fit into that thing. There's numerical data. Georgie gave a good talk on the different alternatives you can do there. And sometimes they don't know the set of possible values. I know with the government data sets, that's very well documented. But sometimes some customer will come in and they don't know what the possible values are for a given column. There's situations where, some columns will be set valued attributes. So it could be like topics. It could be 1, 2, or 3 topics. And the number of possible topics is 400 or something. Now you have a very large space, and I guess I'm not providing answers to how you solve them, but I think the point is, like, when someone comes in with a new data set that doesn't neatly fit into the assumptions of the mechanisms, you kind of have to think of clever ways to map it into this sort of discrete domain. And then I guess it's really just driven by the data sets that we're given. So if we're given a data set with one characteristic, we'll come up with a solution for that. And then now in the future, when someone has a similar problem, that can be solved potentially. But I think there's a whole large landscape of things you could do, and more work is probably needed. But
So encoding becomes really interesting. So I'll turn it over now to the audience. Jack, yeah.
So we also offer some synthetic data, and I was really hesitant to support that. And ultimately we did, because for certain use cases, they wanted to spend their budget once, and then be able to share it, and know that it's going to, as opposed to like an interactive release or something. The reason I'm like very hesitant about it though, is because it kind of miscommunicates, or it can kind of miscommunicate what you're actually giving. So instead of talking abstractly, like say we talk about MST or AIM or any of these, for example, the truth is you're taking a set of marginal histograms usually, maybe a few pairs, or I mean, depending on how it's parameterized, and that's what you're releasing. Everything beyond that is kind of like a fugazi of made-up randomness to make it look like it's an actual data set. But as humans, we have this ability that we very often find patterns in randomness. Like, Nicholas Taleb, Fooled by Randomness, great book, right? We often see things that don't really exist. And so sometimes I fear when we remove the actual thing that is a bounded, known thing, like a histogram, and that the results are within 95%, around some error bounds or something, and you move it into a space of there's a lot of randomness in here, that can be misused, and then like decisions can be made that ultimately have knock-on effects. Even the modality, like if I train a very simple model, and let's say it's just GMM with 3 bumps, and my population has 4 groups of people, well, sorry, group 4, you're not being represented, and we don't care about you. And there's no way for the upstream user, unless they really understand the nuance of the algorithm itself, and then how the production of all of these rows of data were created, to know that we've just lost population 4, which might be like important. So I know like in the conversation, a lot of it is like, oh, people are naive, but we showed them because we're really smart. But like sometimes I think we can do the opposite and like kind of over-promise with the synthetic data that we give to the end users.
I'm going to pretend I'm on the panel.
Yeah, I'm playing devil's advocate.
Yeah.
Like, there's obvious reasons for synthetic data too, but I'm
Sure.
just trying to.
Well, so I'll tell you, so there's a few things you can do about that. First of all, just don't use GMM. But second of all, what we do, what Nexus does in its work, and also what we do for NIST, is we evaluate absurdly exhaustively. So, and I'm not necessarily saying here, our synthesizer is not, it's not AIM or it's not MST, so it's not doing histogram as the intermediary. But sorry, lots of things to talk about here. But the main thing is, we will do, for instance, all regressions that you can possibly do across the data. So all logistic regressions to predict any class that's got more than 100 records in it. We'll go talk to the stakeholders, and we'll see, what general types of analyses they're doing, and then we will do all of them the same way that you would do like K-marginal. And that means that we're checking to see that not only are things that were significant still significant, but that things that were insignificant are still insignificant. And this comes from several very valuable years of having the analysts not the privacy people, but the analysts at the US Census yell at us, and Steve Ruggles and at IPMS yell at us, and so on, and taking sort of all their criticism on board and automating it. And some of these things are available for anybody on this SD-NIST evaluator. But we find that you're right. So, for instance, the TVAE synthesizer, That regression thing I just described is beautiful. It turns the whole thing orange, which is to say all the regressions become significant because the autoencoder simplifies the distribution of the data that now it thinks you can predict anything you want to. But, you know, the good quality data doesn't do that. And I don't know how, but it will match on all the regressions. And we do find that there's a lot to be said about independence between features in synthetic data. So in the real world, there is a lot of independence. And if I don't, there just is. There is between sets of features, and I don't know exactly where it is, but there are places where this feature doesn't affect that feature. And so if I don't collect any information about, and this is where MST does nicely, if I don't collect any information about the connection between these two features, then not GMM, but a good synthesizer won't introduce any connection between them, and you'll get that same lack of signal there that you had in the original data. And that's very hand wavy, but there's a nicer.
So you could, for example, with AIM or MST or whatever, just say these are the marginals. We chose good marginals for you.
And some people will be able to use that. But we also frame it in terms of copious utility metrics, in terms that the folks using the data expect to see. Claire is in California, and I have no idea what time it is here, but I will also add a Claire-shaped plug that goes verification servers. So there is you let people run things on the synthetic data, their own things on the synthetic data, then you run them on the real data, and you give them a different, private. And for applications, that works. But yeah, but you can get absurdly high quality synthetic data, which is fine. Then your verification server will give you a thumbs up all the time. Now that I've talked to Jack for a long time, would anybody actually on the panel like to talk about this too?
I could say something briefly. So yeah, no, I totally agree with you, and that's one of the first things that I'll, when I was, up onboarding some of the people who are interested in it about synthetic data, it's not going to be useful for all downstream utility or all downstream tasks that you want. It can be used as a drop-in replacement, but whether or not it will be good is not something we can formally guarantee, but through empirical evaluations, we kind of know that it's useful beyond just the marginals. So there is, I guess, some benefit to probably providing the noisy marginals themselves, and on top of that saying, if you want something else, here it is. You can use it for anything, but just be a little bit careful. And I think there is some research that tries to do uncertainty quantification by saying, here's the sets of queries that we can provide some bounds on utility on, and that goes beyond what was just measured sometimes. It can be also things that were not measured. But I think a complementary empirical and sometimes theoretical guarantees can help there.
Yeah. The way I think about that is to release synthetic data responsibly. It's not just the data, it's not just the CSV file. It has to come with guidance for what it's relevant, and not only that, I think also this kind of the community of the thinking of computer science, the ideas of guarantees. I think we need to be able to, we should provide also utility guarantee for every release. And this at the end of the day, it's question what I call synthetic data has the same affordance as the original data, right? You can run whatever analysis on that. So in kind of the release we did, we had actually the third page of our documentation is look, this is the kind of queries you might run, and this is the specific guarantees I give you. And I think we can still give very broad type of queries. Now here is something that I'm thinking for a while. I think actually it would be really cool if every synthetic data would release with manifest, something that, for example, Pandas plugin could read. And if I write a query that is outbound, I get a warning like that. We really need to think from usability perspective, how people are doing their analysis, and integrate to this process as well. And at the same time, if a user decide, I ignore the README, I'm going to do one analysis, we cannot take responsibility for that, right? We need to do our best effort and kind of have norms and best practices community, but at the end of the day, we cannot take the responsibility from the user as well.
I do want to add to that real quick. So one thing we like to do is we call it the 40% subsample baseline. So we say, okay, what is the for whatever quality metrics, whatever you want to do, what is the distance between the real data and the synthetic data? I've got that distance metric. And now what is the distance between a 40% subsample of the real data and the real data? And if the synthetic data is as close to the real data as a subsample is to the real data, then you're doing pretty good. Because a thing that happens in reality, the American Community Survey releases with something called, it's the replicate variables. Has anybody here even heard of that term? Or probably a lot of people have heard about the ACS, but you don't know that there's another 80 columns tacked on the end that you are supposed to use to estimate variance error in all of the uses that you do for the ACS. Because the ACS is only a 2.5% sample of the US, and if you're working on the public data, it's a random 1%, it's a random 40% subsample of that. So there is a lot of sampling error in the ACS, even before privacy was done to it in any way. And so there are these variables that you're supposed to use to compute variance on all your statistics anytime you use the ACS. And they're not hard to use. They sound weird, but you just take them, you multiply them by things, it's a thing. Replicate weights. Nobody uses them. So I think at some point we have to hold ourselves to something like the standard. We're not always reaching it, right? Like we need to reach that standard that's used for data releases before we came into the room, but we can probably calm down on getting too far past it. So if we were as accurate as the ACS, I pretty much figure we're okay. It's my personal take, but okay. We've got 10 more minutes. One thing I wanted to talk about, first of all, if there's any other questions on this, we can, oh yeah, please.
I don't know how quick this question is, but.
Oh, no worries.
So in kind of a relation to what you just said, there is, I feel like there's maybe like a reverse problem when you're dealing with synthetic text generation or just like blob text generation, because you have to worry about, is the LLM injecting, more marginals from, memorized data than I actually intended it to do? Do we have a solution for that?
What do you mean by marginals?
Or rather, it's like we've made sure to preserve some marginals when we try to create synthetic like blob text from some initial data set of blob text. And if the LLMs that we're using to generate the final text have memorized something about those individuals that we didn't actually expect because they're huge and perhaps there is some information about them, it might actually reintroduce the things that we tried to make private. So rather than the things that we didn't care about being noise, the things we didn't actually intend to, or the things we didn't care about become identifiable. Any thoughts?
So I'm not 100% familiar with the methods that are for blob text generation and use marginals. Can you speak a little bit more to that?
Just like a concrete example.
I'm thinking a little bit along the lines of something that the thing that you had presented, I think, yesterday.
Okay. Oh, okay.
Something
Gotcha.
along those lines. Like
Yeah.
if suppose you're passing through some histograms and you do DP on those histograms and then you use that to then regenerate some text.
Okay.
Is like that end step might have memorized some stuff about the people that generate that histogram, and then you might reintroduce those specifics in
so I
some
think
way that you can't control.
Okay, good question. Yeah, I think that's where DP provides the guarantees that we're relying on, and I think that'll depend on how strong your privacy budget is. If you're using Epsilon 1, you can say something very strong about what it memorized or what it learned, and if you're using Epsilon 10, then you kind of can't, but you have to complement that with some empirical analyses like tax and things like that, audits. But yeah, that is a concern, especially when you're doing stuff with free-form text.
Like my thought would be if I gave that text to like some engineers and they went through and did some analysis on it, they actually might make correlations that we didn't expect, which are true correlations, not ones that are just like noise, but true because they were injected by some other system that we hadn't done DP on.
Oh, okay. I am sorry I missed everybody's talk here because I was moderating a panel in the other room. But in case anybody else also missed those talks, can you explain a little bit more of either one of you the system that we're referring to here?
Maybe you can talk about the non-private portion that you're.
So it's just using an LLM as, using a non-private LLM and like fine tuning it on differentially private stuff, but we're worried about the,
Yeah, I think at least broadly the pipeline in my head is something like we have a bunch of text, we then generate some tables of important metadata, we make histograms of those tables, and do some DP on those histograms, and then use an LLM to take those histogram and then return text again. So ideally, the text we then produce should have the same, the same histograms, you know, up to DP as the original text, but it's just different. But if the LLM that's regenerating those text actually understands something about the, you know,
I
the people
see.
that went into that
I see.
histogram, that, you know, it might reintroduce specifics about those people that are identifiable that we couldn't capture in those histograms.
right.
So rather than the columns we generate being noise, the columns we generate are actually specific.
So essentially, anytime you've got an LLM that you're feeding differentially private data and you're expecting to get more things out of it, you have to worry about what the LLM may already have memorized, and maybe that's not interesting for like 85% of your folks, but if I'm the only person in this room besides Gary who knows what SD-NIST is, and you've got some portion of your matrix that's, you know, talking about SD-NIST and various words in common, and the LLM is better at checking my website than anybody else, so it also knows me and SD-NIST, the second LLM, right? Then we have potentially a problem of the LLM attaching things to the private data that it had previously learned. That's interesting.
Maybe just a plug for Roy, Salil's PhD student, postdoc, PhD student. He has a really interesting blog on this, basically exact topic, which is around if your information is correlated with public information, and then challenges around DP constraints and other types of privacy violations that might have happened due to like that kind of like undirected data going via like background information that can correlate.
We're not reintroducing like uniformly sampled noise. We're reintroducing noise from like a very specific prior, because we've trained it on like the whole internet or something.
Yeah. We've got,
I'll put that in the slide.
yeah,
Cool.
two or 3 minutes left, and I want to make the best use of the 2 or 3 minutes I possibly can. And here's what I'd like to do with those 2 or 3 minutes, which is, oh, do we have someone over there?
No, I was just.
Okay. Here's what I'd like to do with those 2 or 3 minutes. Can we name the thing you just described? Because we're all going to have to worry about it this year, right? So one of the things is we are like, everybody's figuring out how do you fit into the new era, right? And so differential privacy in part fits into the new era because you can feed your LLM differentially private data. And certainly we don't want to suggest to the new era that differentially private data is not good enough to be a safe way to feed your data in. But at the same time, maybe let's be aware of there should be some sanity checks for leaked memorized stuff from whatever LLM you're doing. Does anybody want to propose a name for that problem? Does your what was the name of the student? Yeah, Roy.
I don't remember whether Roy has it's also related to this position paper by Gautam Kamath and Nicholas Carlini and others. And I think we shouldn't fool ourselves into thinking the fact that we're doing DP doesn't erase the privacy problems that may exist with the LLM that's trained on, you know, so-called public data. I don't know if there's a good concise name for that, but don't expect that because we're feeding in something DP, all of a sudden whatever's memorized inside the LLM gets erased.
So do we say maybe what needs to happen there is you've got your differentially private data that you're feeding it, your co-occurrence matrix or whatever. You can do some red teaming on your LLM. You can say like, hey, we fed this information. It was supposed to be, you know, safe. Talk to our users, see what their concerns are for privacy. Make sure the use of the LLM on the differential private data. If we run some queries, it doesn't seem to be producing problems. I think that's where society is at the moment. Cool. All right. 1:19. In that time, does anyone up here, do you have any last comments or insights, sort of looking forwards to like the future of synthetic data? Like what is the cool, interesting thing that you're hoping for this year in synthetic data? All right. Yeah,
Sorry, the this year was, yeah.
okay. Next 2 years, it's fine.
Yeah, I mean, I think one thing that, so we came far, the community. I think one thing that's, at least for me, super interesting and not really solved, there are a few ideas, also Georgie published something on that, is actually how we can generate synthetic data subject samples that actually interact somehow, right? Because right now, they are independent draws,
Yep.
and that limits the usability and how, so A, how to solve that, and then how to make sure privacy is preserved in such a scenario is the next big topic then, I guess.
I love it. So linkable synthetic data. Right, Slummy?
I want to do two things very quickly. One of them actually related to the conversation of the LLM. I'm happy to talk about this more. How to use LLM to seed DP releases without consuming privacy budget, and how to do it right. I have a paper of that, happy to talk about it. And if you if you have work about this area of actually responsible synthetic data, Rachel that just left, we together co-organized with other people. Oh, here she is. This was like completely, this, in Triple AI in Singapore in January, a workshop about responsible synthetic data in the era of foundation models. So on that spot, submission deadline in 1 month and a day. So just 4 pages abstract, so please do that. And we're looking for reviewers.
I've got some travel budget left, Gary. Ryan?
I guess for me, I think I'm excited about like the software landscape and helping improve that, and making it easier to use. I think what mostly AI has done, I think, is phenomenal with how easy to use their APIs are. And I know like the code that I've previously released from when I was a grad student was very experimental and research based. So I hope that it worked well for people who that used it. But it was
hard to read.
Yeah, no, I totally agree. So that's what we want to move towards in the future.
We would love to see AIM. MST and AIM have gotten a lot of exercise, and that is a credit.
Yeah.
Nothing I did in grad school that got that much use, but I'm looking forward to version 2.0. That would
Cool.
be brilliant. And you're going to work with the guy who's got all the encoding. Who used to work at Hazy, and now is it
Oh, yeah.
Georgie?
Oh,
Thank
yeah.
you.
Yeah.
Work with Georgie on that.
Yeah.
All right.
Yeah.
So we've got our game plan for next year. Thank you very much. And I turn this back over to Sharon.